He knows a lot about the science stuff. Professor Dave explains.
Today we're going to look at a few Grignard reactions. So you've probably gone over this in lecture in your class, or you've watched my tutorial on Grignard reactions. And so very simply, probably on a test, you're going to have to be able to draw the products of some Grignard reactions. So I've drawn three right here. Here's a substrate and a Grignard reagent, another substrate and another Grignard reagent, and then here we have an ester substrate and an excess of a Grignard reagent. So that should give you a hint of what to do there. So go ahead and give these Grignard reactions a shot. Okay, so when we're doing Grignard reactions, the key thing to remember is that it is always the carbon that is attached to the magnesium and the carbonyl carbon on the substrate that are going to generate a new carbon-carbon bond. This is because the insertion of the magnesium atom into the carbon-bromine bond reverses that polarity. We're going to have a partially negatively charged carbon atom, so that is a source of nucleophilic carbon. And then once again, we know that a carbonyl looks like that. We've got a partially positive carbon. A carbonyl carbon is partially positive. So any reaction in chemistry is always electron excess meets electron deficiency. So that's how Grignard reactions work. So in this case, we know that this carbon is going to go ahead and attack there. Pop that up, a little bit of acidic workup, and we'll get the alcohol. So this is the new bond that we have formed right there. Okay, these two carbons came from the Grignard reagent, and these four were already there. So let's number them. 1, 2, 3, 4. And then this is going to be 5 and 6. 1, 2, 3, 4, 5, and 6. So 5 from the Grignard reagent, the one that was nucleophilic, and 4, the carbonyl carbon, now have that new bond between them. So remember that that is always going to be the case for Grignard reactions. Now once again right here, let's number these. 1, 2, 3, 4, and then we've got 5, 6, 7, 8, 9. It is going to be, once again, this is the carbon that is connected to magnesium. This is the carbonyl carbon. You're going to have that attack here. Pop that up. That'll get protonated upon workup, and we've got our alcohol. So here, we need to make that new bond. We need to show that new bond. But then a very common error is to create the correct connectivity, but then have something weird happen with the other carbons. Remember that the only thing that has happened is a new bond between this carbon and this carbon. Everything else that is there simply remains where it is. So that's why it's sometimes good to number our carbons like that. We know that we've made a bond between 2 and 5. So there's 5, or sorry, there's 2 and here's 5. And then let's number around the ring like we had, 6, 7, 8, 9, and then connected to carbon 2 on this substrate was carbon 1, the methyl, so that's still there, nothing happened to that, and then 3 and 4 right there, those are still there, nothing happened to those. So if you're having a difficult time visualizing the transformation itself, usually you can number the carbons, and then if you just say to yourself 5 and 2, there's a new bond there, and then everything else that those were connected to, they're still connected to. So 2, there's 1, 3 and 4, etc. So there's our product for that one. Now this one's a little bit different because we have an ester substrate. And if you recall from my Grignard lecture, we know that an ester substrate in the presence of excess Grignard reagent can undergo 2 consecutive Grignard reactions. Because what happens is, so this is, all we have is this methyl here, so that is going to attack. That can go up there, and then we get the oxyanion, but then instead of protonating, this can actually come back down and kick off the alkoxy group. So we have added our Grignard, we have added our methyl Grignard reagent right there, that's the new methyl, and we've kicked off that alkoxy. But in kicking off the alkoxy group, we regenerated the carbonyl. And we know that any ketone or aldehyde is susceptible to attack from a Grignard reagent. So if we have excess Grignard reagent, at least 2 equivalents, that means that we can do this again. Another Grignard reagent that's swimming around can find that ketone, and now all of a sudden we have added another methyl Grignard reagent. And so what we can see here is by kicking off the alkoxy group, we regenerated the carbonyl. There's one equivalent of our Grignard reagent, and then we can go ahead and do it a second time because that carbonyl was regenerated, and we've got another methyl group attached onto there. So these are the products of some of these Grignard reactions. Thanks for watching, guys. Subscribe to my channel for more tutorials, and as always, feel free to email me, ProfessorDaveExplains@gmail.com.